Alright, so this is a lesson that we have for covalent bonding. So I'm going to 6.2 covalent bonding, page number 146. So we are going to continue our lessons on covalent bonding here. When we talk about covalent bonding, we are talking about bonding between non-metal atoms, two or more non-metal atoms. Alright, when you're talking about bonding that involves any metal atoms, that is not a covalent bond. So make sure we are very clear on that. When we're talking about ionic bond, when we're talking about metallic bonding, they are very different from covalent bonding. So covalent bonding is really only for non-metal, and it's talking about the sharing of electrons between these non-metal atoms. So eventually, it says here, enable them to have a full valence electron. What does it mean? As you probably still recall from what we have done in class, we are talking about the octet rule. You want to have the sharing of electrons that enables them to fulfill the octet rule, which is having a maximum of 8 electrons in the outermost shell. Once again, there are some exceptions to this rule. When you're talking about hydrogen or helium, it just needs 2 electrons in the outermost shell for it to become stable. Alright, so make sure we are very clear on this when we're talking about covalent bonding here. We are talking about sharing of electrons or sharing of valence electrons. Valence means the outermost shell, so only the outermost electrons have been shared. And eventually, they want to have a full valence electron shell. So I'm going to move on to the next slide. So it says a single covalent bond. So we are looking at single, double, triple covalent bonds. Make sure you're very clear with the concept. If you know the difference between them and you know how to draw covalent bondings, then you are on the right track. So it says here, when atoms share 2 electrons, one from each atom, the covalent bond formed is called a single covalent bond. 2 examples of substances that contain single bonds are hydrogen and chlorine. So I'll show you the diagram of how hydrogen and chlorine looks like. As you can see here, this is for hydrogen. So as we are probably aware as well, hydrogen has 1 electron. It has 1 electron, which means it has 1 valence electron, as you can see in this diagram here. So each hydrogen, the atom has 1 electron. So what does it want to do? It wants to have maximum of 2 electrons. That's what we have discussed. It wants to fulfill the octet rule. Because having 1 electron in the outermost shell is not stable. So in this case, both hydrogen atoms will share 1 electron each. Eventually, both of them will have 2 electrons in the valence shell. And that enables it to be stable. So hydrogen, H2, is a covalent molecule because it's a sharing of the valence electron between 2 non-metal, in this case 2 non-metal atoms. So make sure we are very clear on that. It says in this molecule there is formed, so I'm bringing the bottom part for you. It says 2 hydrogen atoms share 2 electrons, one from each atom to form a single covalent bond. It says the atoms of hydrogen are now strongly bonded together by 2 electrons in their outer shell. Alright, so once again, when we're talking about hydrogen atoms here, it's a sharing of their valence electrons, and when they both share 1 electron each, they will have 2 electrons in the outermost shell, enable them to be stable. So this is the first example that we have, which is on hydrogen. I'll show you the second example, so I'm just going to move on to the next slide. Alright, so this is on chlorine. It says a chlorine atom has an electronic configuration 287. This is based on the Bose model. Once again, when we talk about the Schrödinger model, it will be 1s2, 2s2, 2p6, 3s2, 3p5. So it means that it has a total number of 7 valence electrons. It needs to have 1 more for it to be stable. Alright, so 7 valence electron because it's in group 17. It has 7 valence electron. It needs 1 more electron for it to become stable. So what chlorine does here is that it will share that 1 electron with another chlorine atom because both of them do need 1 extra electron for them to be stable, as you can see in the diagram at the bottom here. So I'm just going to highlight this for you. So you look at chlorine Cl2, you can see that each chlorine atom will share 1 electron with another chlorine atom. Eventually they will become stable, which means they will have 8 electrons in the outermost shell, which means that they fulfill the octet rule. Alright, so if you talk about chlorine molecule, chlorine is in group 17, but because it is not stable by itself, you can see that chlorine exists as Cl2 because it wants to fulfill the octet rule. So by sharing that one valence electron enable each chlorine atom to gain one extra electron for them to be stable. Alright, so make sure we're very clear on this when we're talking about simple covalent bond or the one covalent bond. In this case, we have chlorine and we have hydrogen as well. So I'm going to move on to the next slide. Alright, so I'm just going to continue on this. So this is talking about the electron dot diagrams. There's two different model or theory that is being mentioned here. So I'll highlight the first one for you. The first one is the electron dot diagram. I'll highlight this in yellow. And the second one is the valence structure. There is a difference between electron dot and valence structure. When we talk about electron dot diagram, it says that it shows the valence shell of electrons as any electrons in the valence shell of atoms are involved. And when we talk about valence structure, it says lines are being used to represent the two electrons in the covalent bond. So the point here, as you can see, when we talk about electron dot diagram, once again, it is also known as the Lewis structure. If you look at the diagram, which is diagram A, you can see that in this case, one electron is being shared by each chlorine atom. Eventually, you have Cl2. So the bonding pair of electron is being represented and the lone pair of electron is being represented by the dots or crosses, as you can see in this diagram. But if you look at the valence structure, it's quite similar. The difference is that it uses the line. So it says one line represents one pair of electrons. It uses a line instead of the dot. That is the difference between the electron dot diagram and the valence structure. So once again, electron dot diagram shows the valence shell electrons, how many electrons has been shared and how many electrons are being left as lone pair. Valence structure is quite similar, but instead of using dot for the bonding pair of electrons, it uses the line to represent the electrons that have been shared between the atoms. Alright, so make sure you're very clear on this. So electron dot diagram is known as the Lewis diagram, and the valence structure is known as the valence structure also, of course. The difference between them is the bonding pair of electrons. For electron dot diagram, it uses dots or crosses to show the bonding pair of electrons, whereas for valence structure, it only uses the line to represent the electrons that have been shared. So I'm just going to move on to the next slide. Double covalent bonds. So we have done simple covalent bonds. Now we are moving on to double covalent bonds. It says in the double covalent bond, two pairs of electrons are being shared between atoms instead of just one pair. So make sure you're very clear. When we're talking about simple or single covalent bond, we're talking about one electron is being shared between the atoms. Double covalent bonds means two electrons are being shared between the atoms. If triple covalent bonds, you probably get it by now. 3 electrons is being shared by each atom. Alright, so in this case, oxygen, as you know, oxygen is a group 60. Oxygen is in group 60. It has an electron configuration. Here, I like this for you, 1s2, 2s2, 2p4. As you can see in the second shell, it has 6 valence electrons. But it means that oxygen wants to have 2 more electrons in its valence shell for it to become stable. So what it does is that it wants to be able to share 2 electrons with another oxygen atom. And the other oxygen atom is also sharing 2 electrons with this particular oxygen atom. Eventually, each oxygen atom will have 8 electrons in the outermost shell. Right, so make sure we get 8 electrons in the outermost shell, and that is what we want. We want it to fulfill the octet rule. So when we talk about oxygen molecule, it has a double covalent bond. As you could probably picture it in your head right now. If you are going to draw the valence structure, you will know that it's going to be 2 lines because each line represents 2 electrons. So because each oxygen atom shares 2 electrons with another oxygen atom, eventually both of them will be able to fulfill the octet rule. So they will have 8 electrons in the outermost shell. Alright, so make sure we are clear on this. So this is on double covalent bonds. I'm just going to move on to the next slide. Alright, so this diagram shows the oxygen molecule. It says each oxygen atom contributes 2 electrons to the bond between atoms. Each oxygen atom contributes 2 electrons. And since the diagram here, diagram A, you have the electron dot diagram. the electron dot diagram or the Lewis diagram that we have discussed. It shows that the oxygen or each oxygen atom is sharing 2 electrons with another oxygen atom. Eventually, we have 8 electrons in that atom. Can we count that? If you look at diagram A, each oxygen will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. For the second oxygen, we 1, 2, 3, 4, 5, 6, 7, 8. So I'm just going through this one here. So this first diagram, this is the electron dot diagram for oxygen. The second diagram that we have is the valence structure. The valence structure. So what is the difference between valence structure and electron dot diagram? You can see the valence structure uses line to represent the electrons that have been shared, whereas electron dot diagram uses dots or crosses to show the electrons that have been shared. So there is a difference between the valence structure and the electron dot diagram. Alright, so we should be very clear. So this is the valence structure. Alright, so electron dot diagram, and now I'll highlight this for you. I'll draw this. So electron dot diagram is A, valence structure in this case is B. Alright, I'm just going to move on to the next slide. Triple covalent bond. Triple covalent bonds. When we talk about triple covalent bonds, we are talking about 3 electrons that be shared between the atoms. So it says here, a triple covalent bond occurs when 3 electron pairs are shared between the 2 atoms. Triple covalent bond. So you see a nitrogen molecule contains a triple bond. As you're probably aware, nitrogen is in group 15, which is 5 valence electrons. As you can see in the second shell here, this is the valence shell. Yes, 2s2, 2p3, which means there are 5 electrons in the valence shell. So what it needs 3 more electrons for it to fulfill the outer role, because it wants to have 8 electrons in the outermost shell. So it says here, when it bonds to another nitrogen atom, each atom contributes 3 electrons to the bond that forms. I'm reading the last sentence of this paragraph. When it bonds to another nitrogen atom, each atom contributes to 3 electrons, which means that eventually they will have 8 valence electrons. 5 plus 3 is 8. I'm just going to move on to the next slide to show you more about nitrogen, and it will make more sense when I show you the diagram. So I'm just going to move on to the next slide. So this is your structure of nitrogen. As you can see, that each nitrogen will have 5 valence electrons. Both of them will share 3 electrons with another 3 valence electron with another nitrogen. Eventually they have 8 electrons in the outermost shell. So 1, 2, 3, 4, 5, 6, 7, 8 for the first nitrogen, and 1, 2, 3, 4, 5, 6, 7, 8 for the second nitrogen. Alright, the diagram at the bottom, you probably can tell it by now. This is a valence structure, so I'm just going to do a circle here. This diagram here is a valence structure. Why is it valence structure? Because the bond it's been the electrons that have been shared is shown by 3 lines here. So the lines represent the electrons that have been shared. So in this case, there are 3 lines because it has three bonds. All right, that's why it's known as the triple covalent bond. So nitrogen eventually will have 8 valence electrons. Each nitrogen here will have 8 valence electrons. All right, so I'm just going to move on to the next slide. So polyatomic molecule. So if the atoms of one element have a different number of valence electrons from the atoms of the element it is bonding with, the molecule that is formed may not be a simple diatomic molecule. It's a molecule made up of more than 2 atoms are known as polyatomic molecule. As the name suggests, monoatomic means one particular type of atoms coming from one element. If it's polyatomic, means it can come from more than one element. There's 2 examples of polyatomic molecules, water and methane. So we go through water and methane. Water has a chemical formula of H2O, methane is CH4. So we discussed how it works, and both water and methane are examples of covalent molecules. So make sure we're very clear on them. I'm just going to move on to the next slide. So this example is on water. It says when a compound forms between hydrogen and oxygen, an oxygen atom shares 2 electrons and the hydrogen atom shares 1. It says to resolve this imbalance, 2 hydrogen atoms each share 1 electron with an oxygen atom. It says as you can see in the electron dot diagram, a water molecule contains 2 single covalent bonds, each containing a shared electron pair and 4 non-bonding electrons. So as you can see in this diagram here, what this is trying to tell you is that each oxygen is sharing 1 electron with another hydrogen. Alright, try and picture that each hydrogen here will have 1 electron, oxygen, 1 valence electron for hydrogen, oxygen will have 6 valence electrons, which means oxygen needs 2 more electrons for it to become stable. So what it does is share 1 electron each with each hydrogen, and eventually what you will get 2 single covalent bonds between the hydrogen and oxygen, and you have 4 electrons or 4 non-bonding electrons from oxygen itself. Alright, so eventually oxygen will have 8 electrons, hydrogen will have 2 valence electrons, oxygen will have 8 valence electrons, hydrogen will have 2 valence electrons for them to become stable, and that is exactly the point here. Alright, and this is a covalent molecule because electrons have been shared. So make sure you're very clear on this diagram that I'm talking about. So I'm just circle this for you. And this is how water molecule looks like. So I'm just going to move on to the next slide. Alright, so this is for methane. Methane gas is a hydrocarbon. Why is it known as a hydrocarbon? Because it consists of hydrogen and carbon. Alright, so when we talk about methane is quite an interesting example, because when you talk about methane here, it consists of, once again, carbon and hydrogen. We know hydrogen has how many valence electrons? 1 valence electron because it is in group 1. Carbon is in group 14, which means it has 4 valence electrons. So how this works is that carbon needs to have 4 more electrons, so it's sharing that 1 electron with each hydrogen. As you can see in this diagram that I'm circling for you, so you can see that each carbon will share 1 electron with each hydrogen. Eventually carbon will have 8 valence electron and hydrogen will have 2 valence electron, and that is exactly what you want to have, because you want both carbon and hydrogen to be stable to fulfill the octet rule. So in this case, your diagram is complete. CH4 is an example of a covalent molecule whereby each carbon shares 1 valence electron with each hydrogen. Hydrogen will have 2 valence electrons at the end, and carbon will have 8 valence electrons, and they will both be stable, and that's exactly what we want. I'm just going to move on to the next slide. Shapes of molecules. So when we are talking about the diagrams or the examples that we have discussed, eventually you will get a certain shape. Why? It depends on the bonding that you have. Hydrogen and hydrogen chloride here are examples of linear structure. Linear means they are flat, means the angle between that two atoms is 180. So you look at this first example here, you have the angle is 180, so I'm just circle this for you, and the second diagram as well, the angle between, in this case, hydrogen and chlorine is 180 degree as well. Alright, so these are examples of linear structure. I'm just going to move on to the next slide. Alright, tetrahedral. When we are talking about tetrahedral, I'll show you the example in a very short while. So this for methane. It says the electron dot diagram shows the 4 outer shell electron pairs around the carbon atoms. Once again, when we talk about electron, when we are talking about electron dot diagram, we are referring it to the Lewis diagram. Is very different from the valence structure. It's a repulsion between the electron pairs means the hydrogen atoms form a tetrahedral shape around the carbon atom. In this molecule, the bonds between the carbon and hydrogen atoms are an angle of 109.5. So I'll show you the diagram and how it looks like. Once again, we'll discuss more about this in chapter 7. So when we go into chapter 7, we'll discuss more about the shape and how does the shape is being furthered by the bonding between the elements of the covalent molecule. So we'll discuss that in a short while. I'm just going to move on to the next slide. Alright, so when we talk about methane here, you have 1 carbon, you have 4 hydrogen. Alright, the point here is that eventually what happens is that because of certain properties of that particular covalent molecule, bear in mind, even though they do have electrons that has been shared, there is also a certain repulsions between that one atom to another, because similar charge repel. So because protons and protons do repel between the atoms to a certain extent, and eventually they get a particular shape, and in this case the shape that we have is tetrahedral, which means the angle between, in this case, I will just draw this for you, let's say between this hydrogen and the second hydrogen, this will be 109.5 degree, and between the other two hydrogen will be 109.5 as well. And this is known as a tetrahedral shape, once again, I will explain this more in the next few lessons that we have when we are discussing about the different examples of covalent molecules. Alright, so for now, I'm just going to move on to the next slide. Alright, this one here is quite important. It tells you the differences between electron dot, valence, bond state, and space filling. Diagrams can be represented in different ways. In this case, there are four main examples or four main ways that the molecules can be represented. So electron dot is the Lewis diagram, valence is the valence structure, your bond state, your space filling. When we talk about electron dot here, is best used to determine the formula of the molecule and the types of bond. I'm just going to highlight this for you. It is used to determine the formula of molecule and the types of bond. Valence is to simplify the electron dot diagram. Bond state is to display the molecule shape. Space filling is to show the relative size and position of the atoms in the molecule. Alright, so each of these diagram has its own advantage and disadvantage. As you can see, the one that we have discussed so far throughout our lesson here, electron dot, which is the Lewis diagram, it says it is useful to determine the formula of the molecules and the type of bonds. Whereas for valence structure, it simplifies the electron dot diagram. But there are some weakness to both of these methods. You can see the limitation of the model. Highlight this for you. Electron dot, it says that it does not show the relative size of the atoms or shapes of the molecule. The same goes for valence as well, which is why bond state and space filling can come into the context. When we talk about bond state, something looks like the model that you probably come across in a chemistry lab. So for bond state, the limitation of model is that it shows the shape but does not show the relative sizes of the atoms. As for space filling, it shows the relative size and position of atom but does not show the bond angles and types of bond. So once again, there are some weaknesses to each of these models here, but the point here is that when you're writing in general, it's easier for you to write or easier to draw the covalent molecule in the form of electron dot and valence. But when you're trying to represent it, trying to see its 3D shape, then maybe it will be better off using a bond state. And if you want to look at the size and the position of the atoms, then it's better off using the space fill. But make sure you know the difference between electron dot, valence, bond state, and space filling based on this particular slide. So I'm just going to move on to the next slide. Alright, so there's a word example here. It says electron dot diagram, draw an electron dot diagram of methane. Alright, electron dot is the Lewis diagram once again. It is different from the valence structure because valence structure, the electrons that have been shared is been represented by that particular line, whereas in this case represented by dots or crosses. So in this case, you have carbon is in group 14, hydrogen is in group 1. So carbon has 4 valence electrons, hydrogen has 1 valence electron. Each carbon will need 4 more electrons and each hydrogen will need 1 more valence electron. And together, you will get CH4. CH4, you have each carbon sharing 1 electrons with each hydrogen, and eventually we have 8 valence electrons and hydrogen will have 2 valence electrons, and which is why CH4 is now stable. Alright, I'll get you to work on the other example, which is the one at the bottom here. I like this ammonia. Think about this. I'll give you some information for you to work on and then post your answer onto Schoolbox once you're done with that. When we're talking about ammonia and H3, we know that nitrogen, which is in group 15, wants to have 3 more electrons because they have 5 valence electrons. It needs to have 3 more for it to become stable, and each hydrogen will have 1 valence electron. It just needs 1 more for each of them to become stable. So think about it on how you can draw the structure of NH3 and whether is there any lone pair electrons. Lone pair electron means the electrons there have not been bonded. Alright, bear in mind electron dot is the Lewis diagram. It is not the same as the valence structure. Electron dot is not a valence structure. So be sure you're clear on that, which means when you're drawing a diagram, you should be using dots and crosses only. Alright, so that's done for ammonia. I'm just going to move on to the next slide. Alright, we are done for this. Make sure you do complete any questions that has been posted on the Schoolbox page. All the questions needs to be completed. If there's any other assessment, it will be written on the Schoolbox page as well, but feel free to post any question if you have, and then I'll answer those questions for you. Once again, thank you very much. I'll see you in the next session soon. Cheers.